Hello everyone, so I am back with the fourth video on video series on class 9 maths number systems. In this video, we are going to learn about the operations of real numbers. Operations, of course, the mathematical operations like addition, subtraction, multiplication and division. So what we notice is both rational and irrational numbers, they follow the commutative property, associative property and distributive property for addition and multiplication. A lot of you must be thinking, what are these properties? You must have studied about them in your junior classes, but still we are going to do a very quick recap. Commutative property for multiplication tells us that A multiplied by B is equal to B multiplied by A. In case of addition, it tells us that A plus B is equal to B plus A. Next is associative property. It states that if there are three real numbers A, B, C, then A multiplied by B multiplied by C is equal to A multiplied by B then multiplied by C. Similarly, in case of addition, it tells that A plus B plus C is equal to A plus B plus C. Then comes the distributive property, which tells that A multiplied by B plus C is equal to A multiplied by B plus A multiplied by C. So if you see, all these properties are something which we have been learning since junior classes. So all that we are trying to tell is these properties are also followed by real numbers, that is both rational and irrational numbers. Now, please note an important thing here. If we add, subtract, multiply or divide two rational numbers, we get a rational number. But that is not true for irrational number. It is not necessary that if we multiply two irrational number, we will always get an irrational number. For example, root over 2 is an irrational number. But if it is multiplied by root over 2, we get 2, which is a rational number. So the product of two irrational numbers becomes rational in this case. So let us take a look at what are the different operations that we can do between a rational and an irrational number and what will be the output that we will get. So this table will help us to identify it in a better way. So we will do four operations, that is addition, subtraction, multiplication and division. First we'll try with rational and rational, then we'll try with irrational and irrational, then we will try with rational and irrational. Okay, so we will take examples and see what happens. Okay, so let's start with rational and rational addition. So let's try with some examples. Let us suppose 2 plus 2, two rational numbers. When you add them, what do you get? You get 4, which is again a rational number. If we talk about subtraction, let us suppose 2 minus 1, you get 1, which is a rational number. Talk about multiplication, 2 into 4, you get 8, which is a rational number. Divide, 2 divided by 5, which is a rational number. So we see that when we perform all these operations between two rational numbers, the output is always rational. Right? Now what happens when we perform these operations with irrational numbers? Let's say addition. Now in case of addition, let's say root over 3 plus root over 2. If we add them, what do we get? We get irrational number, right? But if we add root over 3 plus minus root over 3, if we add these two, what do we get? We get 0. And 0 is a rational number, correct? So in this case, it is a rational number. That means for addition, sometimes it may be rational, sometimes it may be irrational. Let's talk about subtraction. So in subtraction, root 2 minus root 2 will give 0, which is a rational number. But root 2 minus root 1 is an irrational number. Let's move on to multiplication. Root 2 multiplied by root 2 will give 2, which is a rational number. But root 2 multiplied by, let's say, root 3 will give root 6, which is an irrational number. Similarly, if we talk about division, root 2 by root 2 will give 1, which is a rational number. But root 2 by root 3 is an irrational number. Right? So in these cases, whenever we are doing these operations between two irrational numbers, we notice that the output may be rational or irrational. So both the possibilities are there. Now let us look at the third case where you have one rational number and another irrational number. And if you do addition, let us suppose 2 plus root 3. What is this? This is irrational number, right? So you take any rational and any irrational, the sum will always be irrational. If we do subtraction like 2 minus root 3, this will be irrational. We do multiplication as in 2 into root 3, irrational. We do division, root 2 by 3, irrational. So whenever we have one rational and one irrational number, then the output is always irrational. So this was interesting, isn't it? So we could clearly see with examples that when we perform these operations with two rational number, output is always rational. We perform with two irrational number, the output may be rational or may be irrational. If we do it with one rational and one irrational number, the output is always irrational. So now we are going to look at some questions, and the more we solve questions, the better our concepts will be. Check whether 7 root 5, 7 by root 5, root 2 plus 21, pi minus 2 are irrational numbers or not. Okay, let's take a look. So let's look at this number 7 root 5, one rational, one irrational, and their product. One rational, one irrational, that means the output will be irrational. 7 by root 5, again one rational, one irrational, so the output will be irrational. Root 2 plus 21, again one irrational plus a rational, so the output will be irrational. Pi minus 2, so pi is irrational, 2 is rational, so subtracting one irrational and one rational number, so the output will be irrational. So all of these are irrational numbers. Add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. So how do we do? So both of these are irrational numbers. So this is how we add them. 2 root 2 plus 5 root 3. So wherever we have similar root over, we will put them together. For example, root 2 under root 2, 3 root 3 under root 3. Right? So what will be the value? 2 root 2 minus, so 2 root 2 plus 1 root 2. So this is basically 1 root 2. So this will be 3 root 2. 5 root 3 minus 3 root 3. So root 3 will be there. 5 minus 3 is 2. So not minus, yeah. So 5 minus 3 is 2. So this will be the sum. Multiply 6 root 5 by 2 root 5. So we will multiply the rational number. So 6 into 2 is 12. Root 5 into root 5 is 5. So this will be equal to 60. Divide 8 root 15 divided by 2 root 3. So we will deal the rational numbers together, like 8 divided by 2 is 4. And root over 15 by root over 3 is actually root over 15 by 3. So 3 5s are 15. So this will be equal to 4 root over 5. So this is how we handle the operations with rational and irrational numbers. Simplify the following expressions. So these are very simple simplifications rather. So we will make use of the properties like the commutative property, the associative and the distributive property, and we will solve them. So let's try the first one. 5 plus root 7 into 2 plus root 5. So what we will do? 5 multiplied by 2 plus 5 multiplied by root 5 plus root 7 multiplied by 2 plus root 7 multiplied by root 5. So let's do it. 5 into 2 plus 5 into root 5 plus 2 into root 7 plus root 7 into root 5. So this will be equal to 10 plus 5 root 5 plus 2 root 7 plus root over 35. So this would be the answer. Let's look at the second one. 5 plus root 5 into 5 minus root 5. So this is in the form of a plus b into a minus b. And what is a plus b into a minus b? That is equal to a square minus b square. Right? So a square minus b square. So 5 square is 25, root 5 square is 5. So this will be equal to 20. Let's look at the third one. Root 3 plus root 7 whole square. This is of the form of a plus b whole square. And what is a plus b whole square? A square plus 2ab plus b square. So root 3 square is 3. 2 into root 3 into root 7, that is 21, plus root 7 square is 7. So this will be 2 root 21 plus 10. So that's the answer. Fourth one, root 11 minus root 7 into root 11 plus root 7. So this is in the form of a minus b into a plus b, which is again equal to a square minus b square. That is equal to root 11 square minus root 7 square. So that is 11 minus 7, which is equal to 4. Rationalize the denominator of 1 by root over 2. What do we mean by rationalize? So basically, if you see here, the denominator is an irrational number. Root 2 is irrational. So we have to rationalize it. That means the denominator should be a rational number. So how do we do that? So whenever it is a root over, so we multiply it with the same root, because we know that so for square roots, let's say it is root 2. Root 2, if you multiply by root 2, you get 2. Root 5, if you multiply it by root 5, you get 5, right? So therefore, what we do in such cases is we multiply it with the same square root. So we will multiply the numerator and denominator by root 2. So we get root 2 divided by 2. So the denominator is rationalized. Again, rationalize the denominator. In this case, it is root 3 minus root 5. So how can we rationalize it? So in this case, since it is in the form of a minus b, let us multiply it with a plus b, so that it becomes a square minus b square. Because in any case, we want to make it a square, so that it becomes a rational number. So we will multiply this entire thing by root 3 plus 5. Again, root 3 plus 5. So what happens? The numerator becomes 5 into root 3 plus root 5. And the denominator becomes a minus b into a plus b. So a square minus b square. So this becomes 5 into root 3 plus root 5 divided by 3 minus 5. So this is equal to minus 5 by 2 into root 3 plus root 5. So you see the denominator has been rationalized. So you are getting it, right? So whenever there is a square root in the denominator, if it is a single square root, just multiply it with the same square root. If it is in this form, then think of formulae which can convert it into a square, as in here. Right? Because if you multiply it by root 3 minus 5 only, in that case what happens? It becomes a minus b whole square. So you get a square plus b square minus 2ab, and that 2ab will still be irrational. Therefore, that a plus b whole square or a minus b whole square doesn't work. You need to make it a square minus b square. Classify the following numbers as rational or irrational. Let's try. 2 minus root 5. One rational number, one irrational number, they are getting subtracted. So the result would be irrational. So this is irrational. 3 plus root 23 minus root 23. So if we simplify it, these two will get cancelled. So the answer would be 3. So this is a rational number. 2 root 7 by 7 root 7. So root 7 will get cancelled. So this will eventually be 2 by 7, which is a rational number. 1 by root 2. So this is an irrational number. So even if we rationalize it, but we will still have an irrational number on the numerator. 2 pi. So pi is an irrational number. So obviously 2 pi will also be an irrational number. Simplify each of the following expressions. So see, in this particular part of the lesson, it's more about practicing these kind of expressions. How do you simplify them? That's the whole thing. So 3 plus root 3 into 2 plus root 2. Again, we will make use of the distributive property. So you multiply 3 with 2 and then with root 2. So you get 3 into 2 plus 3 into root 2 plus root 3 into 2 plus root 3 into root 2. So you get 6 plus 3 root 2 plus 2 root 3 plus root 6. That's the answer. Then you have 3 plus root 3 into 3 minus root 3, which is in the form of a plus b into a minus b, which is equal to a square minus b square. So this will be a square minus b square. So that is 9 minus 3, which is equal to 6. Then you have root 5 plus root 2 whole square, which is in the form of a plus b whole square. And a plus b whole square is a square plus b square plus 2ab. That is equal to 5 plus 2 plus 2 root 10. That is 7 plus 2 root 10. The last one, root 5 minus root 2 into root 5 plus root 2. So it is in the form of a minus b into a plus b, which is equal to a square minus b square. So I leave it for you as an exercise. So give it a try. So put it in the form of a square minus b square, that is root 5 square minus root 2 square. So now we are going to talk about the laws of exponents for real numbers. So whenever we have a base to the power something, right? For example, 2 to the power 3 is equal to 8. 2 to the power 3 means 2 is getting multiplied 3 times. So similarly, there are few laws that we need to remember. For example, a to the power m into a to the power n. What if you have the same base? So here a is called the base and m and n, they are called the powers or exponents. So in such cases, a is equal to a to the power m into a to the power n becomes equal to a to the power m plus n. So whenever they are getting multiplied, the powers get added up. Whenever they get divided, the powers get subtracted. So that we will see in the third one. So you see, when they get divided, the powers get subtracted. So a simple way to remember, a to the power m to the power n, that is equal to a to the power mn. That means, let's say 2 to the power 3 to the power 2. That actually means 2 to the power 3 into 2. That is 2 to the power 6. Right? If you have 2 to the power 2 into 2 to the power 3, that is actually 2 to the power 2 plus 3. That is 2 to the power 5. If you have 2 to the power 3 divided by 2 to the power 2, that is equal to 2 to the power 3 minus 2, which is equal to 2 to the power 1. And finally, a to the power m into b to the power m. For example, if you have 2 to the power 2 multiplied by 3 to the power 2, that actually means that 2 into 3 to the power 2, which is equal to 6 to the power 2. So these are the 4 laws which you need to remember. And based on these laws, let us practice a few questions. 2 to the power 2 by 3 into 2 to the power 1 by 3. So we see that the bases are the same and they are getting multiplied. So what will happen to the powers? The powers will get added up. So this becomes 2 to the power 3 by 3, which is equal to 2 to the power 1, that is 2. Let's look at the second one. 3 to the power 1 by 5 to the power 4. So this will get multiplied. So this becomes 3 to the power 4 by 5. Third one, division, same base. So the powers will get subtracted. 1 by 5 minus 1 by 3. So 1 by 5 minus 1 by 3 is equal to minus 2 by 15. This is like the normal subtraction. So that becomes the answer. Okay. Fourth one, 13 to the power 1 by 5 into 17 to the power 1 by 5. So 13 into 17 to the power 1 by 5, which is equal to 221 to the power 1 by 5. Let's practice few more questions. 9 to the power 3 by 2. So we have to simplify it further. So how can we simplify? Well, 9 being a perfect square can be written as 3 to the power 2 because 3 into 3 is 9. So 3 to the power 2 multiplied by 3 by 2 because 3 by 2 was already there. This 2 will get cancelled. So this becomes 3 to the power 3. 32 to the power 2 by 5. So 32, how do we write 32? So just do its LCM. 2 16s are 32, 2 8s are 16, 2 4s are 8, 2 2s are 4. So 32 is actually 2 to the power 5. So 2 to the power 5 multiplied by 2 by 5. So 5 will get cancelled. This is 2 to the power 2. So 3 to the power 3 is what? 27. 2 to the power 2 is what? 4. 16 to the power 3 by 4. So 16 can be written as 2 8s are 16, 2 4s are 8, 2 2s are 4. So this is 2 to the power 4 multiplied by 3 by 4. So 4 4 will get cancelled. This is 2 to the power 3 and that is equal to 8. 125 to the power minus 1 by 3. So what is 125? 5 into 25, 5 into 5. So 5 to the power 3 multiplied by minus 1 by 3. So 3 will get cancelled. This is 5 to the power minus 1 which is equal to 1 by 5. I hope you found the video useful. In fact, I hope that you would have watched the entire video series on class 9th maths number systems. If you liked our video series, please do let us know in the comment section. Also share the video with your friends so that more and more students can get benefited out of this video. So I will meet you all very soon with a new video series on a new chapter. Till then, bye-bye. Take care.